Question 1. Solve for all values of x. So remember, when we have all these fractions here, if we can get common denominators, we can just cross off the denominators entirely. So let's look at this one right here. I notice that that's factorable, right? If I come up with two numbers that multiply to negative 24, that add up to negative 5, that would be x minus a and x plus 3. And hey, would you look at that? Those two denominators also have x minus 8 and x plus 3. So remember, to get common denominators, we just need to multiply each fraction by what it's missing. So this one's missing an x minus 8, and I have to do it to the bottom and the top. And this one's missing an x minus, or an x plus 3, and I need to do it to the bottom and the top. And this one's not missing anything, so I don't have to do anything to it. So 3 times x is 3x, 3 times negative 8 is negative 24, and that's all over x minus 8, x plus 3. This one, I got to distribute the x, and we get x squared plus 3x all over x minus 8, x plus 3. And this one doesn't change. Now all of our denominators are the same, so let's cross them off, and we end up with 3x minus 24 plus x squared plus 3x equals x. I'm going to solve this. When I see a squared, I know I'm going to make it equal to 0, so I can use factoring or the quadratic formula. So let's combine like terms over here. We have 3x and 3x, which is 6x, but when I move this one over here, it'll be plus 5x, and then minus 24. So combining like terms and getting everything on the left ends up with x squared plus 5x minus 24. Now let's factor. I need two numbers that multiply to negative 24 that add up to positive 5. The numbers here would be x, and the numbers here would be negative 3 and positive 8. And then let's solve each of these by doing this. And I solve this one and get 3, and I solve this one and get negative 8. So these are our answers. Part 2 asks, in the space below, state whether or not any of your solutions were extraneous and explained how you determined this. So this question is asking, are these roots extraneous? We should be checking for that automatically already, but the question reminded us to do that. So if 3 is extraneous, that means that it would make a denominator be 0, and we have to eliminate it from our answers. If we put a 3 in there, our denominator wouldn't be 0, right? It'd be 6. If we put it in there, it'd be negative 5. And if we put it in this, it wouldn't be 0. Same with negative 8. If I put negative 8 in there, I'd get negative 16. If I put 3 in there, I'd get 6. So we are going to say we have no extraneous roots. These values did not make the denominator 0. That's all we have to say for that question.